Welcome to the Connect with BMC Helix ITSM and Remedy webinar. During today's session, you're able to ask questions of our panelists. The questions and answers, as well as today's recording, will be posted to the YouTube channel and communities within a week of today's broadcast. Today we have Rajendra and Mark taking us through using the subquery option to optimize row-level security. At this time, I will turn it over to Rajendra.
Thank you, Greg. Welcome everyone to this webinar session. My name is Rajendra Kapale. I work as a lead product developer in Remedy platform team. I am responsible for doing design and development of new features into Remedy platform. Today, me and my colleague Mark are going to talk about a new row-level security implementation called as Subquery option. This new implementation is better performant than earlier RLS implementations. So we want to provide information on various aspects of this implementation, which should help you guys to adopt it for your environments. This is agenda for today's presentation. To start with, we'll see what is RLS or row-level security. What are the existing row-level security implementations? Then we'll move to the details of this new RLS Subquery implementation. We'll also talk about RLS Autodiscovery feature, which will help you to adopt this new implementation easily. After that, Mark will take over and he will talk about troubleshooting and performance aspects for this new RLS implementation. So to set the context, I will start with what is row-level security and where it is used. All of us know that we can control form and field level access using permissions defined on form and field objects. RLS or row-level security is next level of access control using which you can make a specific set of data accessible to specific users or to a group of users. This row-level security is used in ITSM applications for multi-tenancy. An example is incidents created by a specific company user is accessible only to users of that specific company. Please note, RLS is only applied for non-admin users, as AR admin user can access all the data in the system. Before understanding how RLS works in AR system, it is important to understand about dynamic groups and dynamic access fields, which plays a key role in row-level security. Dynamic group is a concept where user becomes part of that dynamic group based on the values in a specific field for a specific entry. There is a field on the form which corresponds to every dynamic group, which defines who is part of that group for that specific entry. This field is called as dynamic access field. Value in this dynamic access field can contain username or a group or set of groups. Different dynamic groups and its associated field are shown on the screen. Submitter, assignee, assignee group are some of the dynamic groups and dynamic access fields. Also, there is a range of group IDs 60,000 to 60999 using which you can define your own dynamic group. The corresponding dynamic access field is also defined using the same field ID range. Let's understand dynamic group concept using an example. If an entry with request ID 1 has submitter field value as Alan, then Alan becomes part of submitter group for entry ID 1. Row-level security is mainly evaluated based on dynamic group permissions defined on request ID field of a form. An example is if a request ID defines submitter and assignee group permissions as shown on the screen, then a non-admin user Alan will be able to access all such records from this form where his username exists in submitter field or his username exists in assignee group field or his groups exist in assignee group field. For query use cases, dynamic group permissions defined on the fields used in qualification and the dynamic group permissions defined on the queried fields are also considered. In this case, all the records which passes dynamic permission criteria for both request ID field and qualification fields are fetched from database. The queried field values for which dynamic permission criteria is not passed are removed from the records, and then the records are returned to user. Now let's talk about existing RLS implementations and their issues. One of the existing implementation is Combined Likes, which is also the default implementation used by AR server to evaluate RLS. Let's understand how dynamic access field data is stored in the T table of a form to know how this implementation works internally. There is a column corresponding to each dynamic access field in the T table of a form which stores values in that field. Multiple group permissions are separated by semicolon in this column value. As mentioned earlier, there can be many dynamic access fields existing on a form. So, there can be many such columns storing security permissions data as shown in the table on the screen. For evaluating RLS, AR server appends the RLS clause to the query issued by end user, so that correct set of records are returned to user. One such query for combined like implementation is shown on the screen. The RLS clause appended by AR server is highlighted in red. As you can see in the RLS clause, username and all of the users groups are compared against the dynamic access field column using like operator with multiple OR clauses. There is one more implementation called as RLS split that is introduced around 9.0 timeframe. In this implementation, AR server evaluates RLS using a custom DB function RLS split for SQL Server database. Whereas for Oracle database, it uses a regexp function. The RLS implementation used across all the forms can be configured at system level. The default system level implementation is Combined Likes. It can be changed to RLS split implementation by configuring disable new RLS implementation setting to false. It is possible to configure different implementation for a specific form. For doing that, you need to define RLS algorithm property via Dev Studio on that form. Now, the main issue with both of these implementation is as the data grows in the tables, the queries starts running slow. This slowness occurs for the queries issued by non-admin users having more number of groups assigned. We typically see the slowness for the users which has around 70 groups or more than that. There are two reasons why this runs slow for the user having more number of groups. First is the query becomes big with those multiple like or clauses. Second is because of this multiple like or clauses or because of a custom DB function, database has to scan through each row that is selected based on the main qualification to further qualify the result set for row level security. Also, the query cannot be tuned for RLS clause using indexes. Queries having like operator used with leading wildcard pattern percentage does not use indexes. Same is the case with the custom DB functions. Custom DB functions also cannot make use of indexes on database. To address these performance issues, we came up with a new RLS implementation which we will talk about in next slides. Let's talk about the new RLS implementation, that is RLS Subquery Implementation. This is introduced in 1902 as controlled access feature and it is GA'd in 1908 release. This new RLS implementation involves separating the dynamic access field data into a new table called as S table or security table. Basically, the data of dynamic access fields is normalized into this new S table. As you can see in the table shown on screen, each semicolon separated value of the dynamic access field becomes a row in this table. This row also has entry ID and label ID or a field ID column which indicates from which entry and which field the value is coming from T table. There is a primary key index involving all three columns on new S table which helps to make the search faster. The query to evaluate RLS using this implementation is shown on the screen. The RLS clause appended by server is highlighted in red. The RLS clause joins T table and S table on entry ID column and the user groups are compared against the label value column using in operator. Since the RLS clause is generated using the new table in a subquery, this implementation is named as subquery. Please note the data for dynamic access field continue to exist in T table. This helps to switch the things back to earlier implementations if required. Also, any application workflows referring dynamic access fields will continue to work without any issues. This new implementation can be enabled per form. There is no way to enable it for all the forms at system level using configuration. As it involves creating a new table, BMC recommends to enable it only for the forms which has large number of records and if that form is undergoing RLS performance issue. This new implementation is supported for regular, join and view forms. We'll see the details around how to enable it and how it works for each form type in next slides. Let's start with how to enable this new implementation for a regular form. Once you decide to enable this for a particular regular form, create an overlay of this regular form using DevStudio. Make the other section as override overlay, and inside the row level security subsection, you need to enable the security table option and select the algorithm as subquery as shown on the screen. Please note that the changes has to be done in overlay layer. By doing so, these changes will remain intact during upgrade. Also, if you notice, there are separate options to enable disable stable and to configure the algorithm. This is just to give the flexibility to switch to a different implementation even though stable exists. But if stable option is not enabled, then algorithm cannot be used as subquery. Once you enable stable option on a regular form, stable gets created for that form in the database. Also, background job is triggered on the admin server, which takes care of populating stable based on the table dynamic access field data. This job's progress can be monitored using a form RLS migration pending. As you can see on the screen, this form shows the number of records processed so far out of total number of records. While this data population is going on, any queries on the regular form which has subquery algorithm enabled will use the system's default RLS algorithm because the stable is not yet ready. Once the data population job is complete, AR server starts using subquery algorithm for the queries. For create, update, delete of the records on table, server will also make the corresponding create, update, delete on table for dynamic access field data. Usually this process of initial data population is really fast, and Mark will talk about some numbers for this from our lab in upcoming slides. Once the data population job is finished, the entry from RLS migration pending form is deleted. As you can see on the screen, the start and end of this data population job is also logged in AR error log file. A sample query for this implementation for a regular form is shown on the screen. The use case is to do an incident search by priority on HPD helpdesk form. The RLS clause appended by server is highlighted in red. As you can see, the T and S tables are joined using entry ID, and the user groups are compared against label value column in the in clause. Let's see how to enable this new implementation for a join form. As join form does not have its own data table, there is no option to enable disable security table on join form. Data for the join form comes from the underlying member forms. So to use this new implementation for a join form, we have to depend on the S tables of the member forms. To enable this implementation for a join form, first step is to figure out the dynamic access fields on join form are coming from which leaf level member forms in the join tree. We need to enable the S-table option on all those member forms which are sourcing the dynamic access fields on the join form. An example can be seen on the screen for a join form AST computer system. On this join form, dynamic access fields 112 and 60989 are coming from a leaf level member form BMC core BMC base element. So we need to enable the S-table option on the highlighted member form in the join tree. Second step is to configure the algorithm as subquery on join form. Except for CMDB forms, please make sure to do these changes in overlay layer. By doing so, these changes will remain intact during upgrade. For CMDB forms, you can do these changes in the base layer itself, as those remain intact during CMDB upgrade. As mentioned in the earlier slide, to get this new implementation working on join form, stable option has to be enabled on all member forms which are sourcing dynamic access fields on join form. But if that is not done, then server will use system's default RLS algorithm for generating the RLS clause. A sample query of this implementation for a join form is shown on the screen. The use case is to do asset search by CI name on AST computer system form. The RLS clause appended by server is highlighted in red. The RLS clause for join form is bit different. Here it joins T view of join form and S table of member form using the E column. This E column on join view points to the entry ID column of a member form that is sourcing dynamic access fields on join form. The rest of the RLS clause for comparing user groups is similar to the regular form RLS clause. Let's see how to enable this new implementation for a view form. The underlying data table for a view form is not controlled by AR server. Hence, there is no option to enable/disable security table on view form. However, an option to configure the algorithm as subquery is provided on view form. But to use that option, you need to create the S table or S view in the database corresponding to the view form data table. This manually created S table structure has to exactly match the S table structure described in earlier slides. Please note, as the S table is external to the AR server in this case, it does not manage data in that S table. And the S table is only used for evaluating RLS. BMC out of the box provides a way to generate S view for some of the ITSM and Smart IT Union view forms. Using that, you can enable this new RLS implementation on those Union view forms. These Union view forms are Overview Console, Smart IT Ticket Console, and Smart IT Social. First step for enabling this new implementation on these Union view forms is to enable the S table option on all the forms that are participating in the union. Please use the SHR Union Configuration Console to know the forms that are participating in the union. The next step is to rebuild the union view using the same SHR Union Configuration Console. This step will generate the S Union view in the database for this union view form. After that, configure the algorithm as subquery on the union view form. Please make sure to do all the form level changes in overlay layer. By doing so, these changes will remain intact during upgrade. Let's talk about a new feature RLS Autodiscovery, which is recently introduced in 2002. This feature has added an ability in AR server to monitor RLS queries. If the execution time for a RLS query goes beyond a threshold, then server reports such query and the form name in a system form AR system RLS Autodiscovery. The threshold is by default 5 seconds and is configurable using a CCS setting RLS Autodiscovery minimum elapsed time. You can configure this setting as per your environment needs. This discovery form can become a potential source of the forms that has to be enabled for new RLS Subquery implementation. As you can see on the screen, the discovery form captures the form name, the SQL query, and the count about how many times this query has been found slow as compared to the threshold. This data can be used to know which forms has potential RLS performance issue. You can enable the new RLS implementation for all such forms. That concludes my presentation. Over to you, Mark.
Thanks, Rajendra. Hello, I'm Mark Walters, a Principal Support Analyst with BMC Software. I've worked in IT for almost 30 years, 20 of which have been as part of Remedy support or engineering teams, where my main product focus has been the Remedy server platform. Rajendra has given us lots of details about how the subquery feature can help improve row-level security performance, and now I want to talk about some steps and techniques that will help you go about identifying and debugging issues with the various RLS configurations. RLS type issues often start with complaints from users about the performance of a particular search or console within a remedy application. These may develop over time, with the system performing well for all users initially, but as the volume of records in forms or the complexity of the configuration, the number of support groups or companies in ITSM, for example, increases, performance begins to degrade. Sometimes there may be a sudden step change as a result of a data import or the crossing of some threshold which triggers a change in the way the database processes queries. The first step is identifying the query that is performing poorly. If you're using a remedy version that includes the RLS Autodiscovery feature, you may find that the work has been done for you and that the queries are already logged in the system. Review the AR System RLS Autodiscovery form to see the details. The Server AR Exception log is also a useful file to review, as it may have captured examples of slow searches that you can use for further investigation. Another option is to enable Server SQL and API logging, and then use a tool such as the Log Analyzer to review those logs and highlight any troublesome SQL. Use the API log entries to identify activity related to problem forms. These will typically be GLEWF or GetListEntry with fields calls. You can then drill down to find the long-running queries they contain. Once you have the SQL, you need to check whether it is an RLS type query. This is usually obvious by the size and complexity of the statement, along with the inclusion of lots of like comparisons with wildcards against the RLS permissions columns, such as C112 and those in the 60,000 range. We'll see some examples on a later slide. If your system is using the RLS split option, you will see the SQL within the groups listed as part of a select using the words RLS split on Microsoft SQL or regex on Oracle. You can then work with the DBA to review the execution or explain plans for the SQL to see if they contain any columns which are candidates for adding to an index to help improve the query performance. There's a tool available on the BMC communities which will allow you to take a query from the logs and run it using the same JDBC driver that the remedy server uses. This provides an easy and repeatable method of running the SQL to get timings and evaluate any tuning changes you make. It's also important to be aware that there are many settings at the database, platform and application level that may impact the performance of your system, both generally and specifically with respect to row-level security. If your system has a large number of permissions groups or users that are members of many groups, you may find that the Hierarchical Groups feature would help. This allows you to reduce the number of groups directly assigned to a user by configuring parent-child relationships between groups. A user may be a member of one parent group, which then grants membership to a series of other groups. This can help reduce the number of group IDs that need to be used as part of the RLS queries, making the SQL less complex and potentially faster. The permissions model in the Remedy ITSM application already makes use of this feature, which may make it easier for you to implement. BMC have a number of requirements and recommendations for many database and server platform configuration options. It's recommended that as a part of any performance troubleshooting exercise, you review both the product documentation and the checklists referenced here. Of particular importance are the database settings, such as cursor sharing on Oracle and parameterization and parallelism on Microsoft SQL Server. If you find that the settings in your environment are different to the recommendations, it may be worth testing the alternatives to measure what impact they have on performance. When you have identified a slow-performing row-level security SQL query, it's important to try and determine whether the cause of the slowness may be related to the RLS or non-RLS portion of the query. The structure of the RLS SQL means that there is very little that can be done directly at the database to significantly speed up this section of the query. The format of the group data stored in the access controlled fields means that the like operators with wildcards or the functions used to parse the values will not benefit from indexing. The There are a couple of ways to help determine whether it is the base or RLS section which is the major contributor to the time taken to run a query. If the steps to reproduce the behavior are simple, you can log in as a user that is a member of the Remedy Administrators group and perform the same actions as a regular user. Administrators have access to all data in the Remedy database, and so the server does not add the RLS component to queries run as this type of user. If the workflow that leads to the query means that you can't use this approach, for example, the query is built dynamically based on settings or data specific to a user, you'll have to run the SQL directly using a client or the JDBC test tool. In this case, you will need to edit the SQL statement to remove the RLS component before running it. Be aware that you will likely get more results returned this way, as you will not be restricted by the application permission model. But if a query run this way takes a similar amount of time to the full query, it is likely that you need to try and make the non-RLS component more selective. In these examples, we can see the non-RLS SQL highlighted in orange. The better qualified this section of the statement is, the fewer records the database has to retrieve before filtering based on the RLS fields. The first statement has a much better base qualification than the second. It includes character status and date-based fields, which help restrict the results. It's worth noting that these are also the fields that you are likely to find will bring performance benefits if you use them in indices. If you are working with a custom application, you may be able to make changes to the workflow to help add conditions to these types of queries. But what about the out-of-the-box Remedy applications? Two of the most commonly used areas of the ITSM application where we see RLS-related performance issues are the overview and various smart IT consoles. These make heavy use of database joins, which combine the records from many tables to generate results lists. In these cases, the application preferences should be reviewed to ensure that only the forms that the users need to see data from are being queried. For example, the overview console, often the home page for many users, can pull data from many forms. If a user is only interested in change or incident data, set their application preferences to restrict the data sources to those forms. This will prevent many of the tables from being queried and should help improve performance. Also consider changing the home page for users to one of the other consoles. If they work only with change requests, make the change management console their default form, avoiding the overview console entirely. Within each console, there are also a set of filters which can be applied to further restrict the data being retrieved. Set these so that only those of interest to the user are returned by default. Assigned to or actionable by the user, for example. Do they really need to see a list of all open incidents, regardless of who they are assigned to or to their status? Through feedback from customers and their support cases, BMC continue to identify and add new indices where they have shown to be beneficial. The reference communities link and product documentation include a list of recommended indices for many products, which you should use to verify that they are present on your system. Another set of configurable options that may help bring performance benefits are those related to results list chunking. There are a range of these settings that may be defined at the server, form, client, and user preference levels, and again the product documentation and checklist describe where and how these may be used. You will see them being used in various SQL queries where they appear as either top N on Microsoft SQL or row num clauses on Oracle. Check that the values are appropriate for the use case leading to the query. For example, does it make sense to bring back thousands of records to populate a table used by help desk agents for their day-to-day work? Consider reducing the size limits if appropriate. All of these options have the potential to benefit not only the user triggering the query, but may also reduce the load on your system and database, thereby helping other users. We have seen that there are three different RLS options: Combined Likes, RLS Split, and Subquery. Due to the wide range of variables that determine how each of these perform, it is important to test and evaluate each one before changing them in a production environment. In Remedy 9 and later, the default RLS option is Combined Likes, but this can be changed at both the form and server level. On a system where you can reproduce the problem RLS behavior, perhaps a pre-production or QA environment, you can easily evaluate the impact of switching between Combined Likes and RLS Split using the centralized configuration form. Select your server under the COM BMC ARSys server component and add or change the Disable New RLS Implementation option. This parameter may not be present initially, in which case the server uses the default value of true. Setting this to false changes the server to use the RLS split format SQL. Note that you shouldn't have to restart the server for a change in this setting to take effect. Just click the Apply button and rerun your test to observe the updated SQL. If you're using a server group and want to apply the setting to all of the servers, you can set it at the shared level component. If you don't want to change this setting for the whole server, you can do so for an individual form. Open the form using Developer Studio and select the Definitions tab. Expand the Other Definitions section and, if this is an out-of-the-box form, set the overlay type to Overwrite, and then expand the row-level security fields. Select from the Algorithm menu to choose between the different options. Note that you can also use the Field ID Order Qualification table to define the order in which the various row-level security fields are placed in the queries. The default is to list the fields in order of increasing field ID, but you may find it helps improve performance for some queries if you specify a different order. If you have forms with many access control fields, and one or more of these have many more groups than others, you can try changing the order using SQL directly against the database to evaluate whether this option may help. This really requires testing, as it's difficult to predict what the optimum order may be, as the database query optimizer will take many different factors into account when deciding how to execute the SQL. Also note that you may find that one set of field ordering works well for a particular query against a table, but not so well for others. This means it may not be possible to identify one best setting for all query combinations. As Rajendra noted earlier, when using the subquery option, the group IDs continue to be maintained in the access control fields on the form. This means there is minimal impact if you switch back from using subquery for a form. However, if it is then re-enabled, the S table is repopulated from scratch. This table shows the availability of the subquery feature in different versions of Remedy. It was added to the server in 1902, but this and 1902 patch 1 require a script from support to enable it and populate the S table data. The ability to enable the subquery option for a form via Developer Studio was added in 1908. And RLS Autodiscovery was introduced in 2002. Autodiscovery has also been backported to all of the versions shown here except 1902, and is either available now or will be soon via a server hotfix. This adds the AR system RLS Autodiscovery form and code in the server to populate it, but it does not include this full subquery feature. BMC believe that auto-discovery is a valuable tool to help Remedy administrators monitor their systems and identify potentially problematic RLS-related queries. This data can then be used to investigate whether the other RLS option available in their version improves performance. They may also be used after an upgrade with the full subquery feature. The final slide shows some performance timing data gathered by BMC both in-house and using customer systems. The first one shows the time taken for the subquery S table to be populated with the group data from existing records on both Linux Oracle and Windows SQL systems for a range of different forms. As you can see, it is a fast process, able to handle hundreds of thousands of records in minutes or less. In some cases, several million records were processed in minutes, while some forms may take a few hours. The timings will vary depending on both the number of records in the form and the complexity of the permissions data that they contain. These tables show the times taken and percentage improvements for commonly run searches using RLS type queries on a range of ITSM forms. As you can see, the improvements can be dramatic, reducing from minutes to seconds in some and halving in others. Note that the subquery performance almost matches that of an admin user, one where no access control is used, for some of the tests. The links to documentation and other references included have been gathered together on this page to help make it easier to find them once the slide deck is made available after this presentation. In this webinar, we have introduced and explained how Remedy uses row-level security to enforce access controls on records stored in its database. Before version 1902, there were two options, Combined Likes and RLS Split, both of which could perform well under some circumstances, but not all. The subquery feature uses a new table to help segregate the permissions data and provide a much more efficient method of querying the groups that have access to a record. This can lead to significant reductions in query execution times, resulting in better performance for users and at a lower load on a system. The troubleshooting section showed how to identify poorly performing RLS queries and provided some suggestions on settings and preferences that may help improve them. We have also seen how the various RLS options may be set and changed for individual forms as well as the whole server. The RLS Autodiscovery feature is a valuable tool to help Remedy administrators identify RLS-related issues on their systems. The data this gathers can now be used in earlier versions to help identify candidates for investigation to see if performance can be improved. That concludes our presentation. Back to you, Greg.
Thank you, Mark. And now I'll take us through the self-help in contacting BMC, our YouTube channel where this webinar will be placed, along with a rich set of how-to videos are available. The Connect with BMC Helix ITSM and Remedy webinar schedule is available via this communities link. It has future webinars as well as all of our past webinars. And the Hot Off the Press newsletter that has trending information is available at this communities link. And finally, contacting BMC technical support via web, phone, email, as well as these social channels. That concludes our session. This webinar, along with any Q&A channel and communities within a week of today's broadcast. Thank you for joining.